Okay, so we have this great PDF put together by the French Petroleum Institute, the IFP. You can see here at the bottom right the name Dominique Bourdet, who you might know is the father of the derivative technique for pressure transient analysis. Now, the PDF is quite straightforward. On the very first page of the file, you see these three columns: Wellbore models, reservoir models, and boundary models. And under each title, you see a list of live links with all the individual models. Now, when you click on a link, for example, this one here, it takes you to the page of that particular model. In this example, I clicked on the infinite conductivity fracture Wellbore model. And what we see here is a little schematic on the top right that depicts the different flow regimes color coded. And you can see the description of each flow regime here on this block of text. And then you see a log-log plot also color coded, showing you the parameters you can extract from each derivative region, which corresponds to the different flow regimes identified. Okay, so in this example, initially we have linear flow, where fluid flows in linear fashion towards the hydraulic fracture, and that shows up on the derivative as a half-slope straight line. And the parameter you can extract from that interpretation is the fracture length or half length. Okay? After that linear flow initially, we transition into a radial flow depicted in red. And what you can extract from that region is the conductivity, KH, and skin. And that radial flow regime shows up as a horizontal stabilization on the derivative, as you know. Okay? Now, if you hit the Control Home keystrokes, you come back to that first page, and then you can go to a different model. So for example, let's go on to a channel boundary model. So I'm going to click on that link, and it takes you to the channel model page. And again, you can see here on that little schematic at the top right, we have initially a radial flow in red immediately when you put the well on production. From that, which shows up as a horizontal stabilization on derivative, you can extract KH and skin. After the initial radial flow, we move on to the emiradial flow because we have seen the first boundary of the channel. So I go from early radial into a hemiradial flow, and you can extract from that transition period on derivative the first distance, L1, which is distance to the first boundary. And then eventually we will get to see the second boundary of the channel. And after that, the whole flow is linear. So on the derivative, that shows up as a half a slope straight line again, and the parameters you can extract from that late times on derivative, which corresponds to the linear flow, are now the two distances to the two boundaries of the channel, L1 and L2. And then again, you can repeat, go back to the first page and move on to whatever model you want to inspect further. Okay, so there you go. I hope you enjoy it. Cheers, guys.